All right, so now we're going to learn about how to add and subtract vectors. The first thing that we're going to learn is called graphical addition. That's when we add it just by drawing, by looking at graphs. So let's add together vectors A and B. We'll say that this is vector A, and vector B looks like that. So vector A, if we were describing, is 3 units long in the positive y. Vector B is 2 units long in the positive x. And so if I wanted to add vector A plus vector B, one way to do it is what's called the tip to tail method. When you do the tip to tail method, I'm going to start at a point, and I'll start with vector A. Vector A looks like this. And then as soon as I draw vector A, I'm going to immediately, where vector A stopped, at the very tip of vector A, I'm going to start drawing vector B. So you can see that I have the tip to the tail, and the resultant vector, the combination of those two, is the sum of those two vectors. So that right there, that starts where A started and ended where B ended, that's the sum of the two vectors. And it doesn't really actually matter what order I do. Just like adding 2 plus 3 and 3 plus 2 gets us to the same place. If I started here and I did B first, I went over 2, and then I went up 2, you can see that I would still end up with the exact same resultant vector. So the tip to tail method is just placing vectors one after another, and then drawing your final arrow from where you started the very first vector to where you ended your very last vector. So that's simple vector addition using graphical addition. I will do one more example. I'm going to take vector A. Um, we'll go with vector A there. Let's go with vector, oh, I ended up doing the exact same vectors. Oh well. Vector B, okay, that one's one longer. Now they're not exactly the same. But instead of adding them, let's try subtracting them. I'm going to do vector A minus vector B. Now this seems like a different problem, but it turns out just like in math, you can rewrite all subtraction problems as addition problems. I can do that here. I could write this instead of A minus B, I could write it as A plus the negative B vector. And the minute that I do that, this becomes very easy because a negative vector always has the same direction, but then the magnitude is exactly switched. So it's still going in the positive x, except since it's negative 3 long, it's going that direction. There's my negative b vector. And if I added vector A minus, or added to negative vector b, I end up with a resultant that looks just like that. And again, it doesn't matter what order I do that in. I can do negative b and then a, and I end up with the exact same resultant vector. So there's graphical addition. Now I'm going to show you algebraic addition. And algebraic addition is also pretty easy. I'm going to use the same vectors. I'm just going to show you how you would add it algebraically. The first thing that we have to do is write out what these vectors actually are. And I'm going to use a different color just so that you can see this new work a little bit easier. Vector A is actually a 3i hat vector. Remember that it only goes, oh, I'm sorry, it's not 3i hat, it's 3j hat, because it's only in the y direction. And vector B is a 2 I hat vector. So if I wanted to add these, I can say vector A is equal to 0 in the I direction and 3 in the j hat. So that would be, it doesn't go over it all, but it goes 3 up. And vector B is 2 in the I hat and 0 in the j hat. So when it comes time to add these together, I could do A plus B, which would be the same thing as 0i plus 3j plus 2i plus 0j. And if I combine the like terms, the i's together become 2i, the j's together become 3j, and I find out that my resultant vector is 2i plus 3j. And if I draw that, let's draw that right here. It's a vector that goes over 2 and up 3. And wouldn't you know it, when I draw the graphical version, I got ugly, sorry. When I draw the graphical version of this algebraic addition, I get the exact same resultant. So that's how we do adding and subtracting with vectors. Multiplying vectors, we won't really be multiplying vectors as a, we'll multiply vectors in a different way, and I'll show you guys that when it's the appropriate time for that. But you do sometimes multiply vectors by scalars, like you might say something like the original vector is go 5 meters, and then they say, okay, go 3 times as far. And when you do that, you just take, if I have an original vector, which was 5 meters, and I want it to go 3 times as long, 3 times a, I just apply that to the magnitude, and it just becomes 15 meters. Oh, I needed a direction. Sure, south. Okay, so that's everything that we need to know for now with vector addition, subtraction, and multiplication. Now let's talk about how we go the other direction. If you're given a vector, how you figure out what its components are and how you figure out what its angle is. So let's start with a new graph, a new vector. Again, we'll put this onto an XY plane. We'll call this the x-axis. This is the y-axis. Let's draw the vector. In fact, I'm going to make this a negative vector just so that, we can see that it really doesn't matter what direction we do it in. Okay, so I have that vector going that direction. And graphically, I can already figure out what the components are. Look, it's going -3 in the x direction. So that's -3 I hat. And it's going +3 in the y direction. So this vector, let's call this vector, I guess we're calling it vector b because I already started writing that. We'll call it vector b. So we already know its components, but using those components, we can realize that this is really just a triangle. And if it's a triangle, I'm going to draw the triangle right here, that has a side length 3, a side length 3, and this is a right angle, then we can already use trig to figure out what the magnitude of our vector is. So I'm going to remind you guys of SOHCAHTOA, or maybe teach you guys SOHCAHTOA, depending on whether your teachers brought this up. But we have these mathematical operations called trigonometric functions, one of which is sine theta. Sine of this angle right here is equal to, I'm going to call this one the hypotenuse. I need to label a couple things here. Let's do that real fast. Let's call this the opposite side, the adjacent side, and I already labeled that one the hypotenuse. So using those names, sine of theta is always equal to the opposite over the hypotenuse. It's just a mathematical fact. It's how we've defined these functions as working. The next one that we have is cosine of theta is going to be equal to the adjacent side divided by the hypotenuse. And then tangent of theta, our last function that we need to worry about, is going to be equal to the opposite over the adjacent. That's the 3 over the 3. So we actually know that for this one, tan of theta is equal to 1, because that would be 3 divided by 3. So that's where SOHCAHTOA comes from. It's sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Using this, we can figure out what our angle must be. We can't figure out the hypotenuse. I went totally the wrong direction. Let's take a step back. We'll come back to this trig. To figure out this length, we're going to use Pythagorean's theorem. Oops. Oh man. Yeah, that's how you spell that. All right, the Pythagorean theorem says a squared plus b squared equals c squared, or as we've written it, the adjacent squared plus the opposite side squared equals the hypotenuse squared. We already know 2 of those lengths. That's 3 squared plus 3 squared equals h squared. That's 9 plus 9, that's 18 equals h squared. So if we square root both sides, we get square root of 18 is equal to h, which I guess we could simplify down to being I think that's 3 square roots of 2, but we don't really have to do that. We've done enough. Okay, we did enough just simplifying to there. You can feel satisfied in our class getting that far. Okay, so that gave us our hypotenuse length. That's 3 square roots of 2. If we wanted to go one more step, and this is where I kind of messed up. I guess I could have used tangent earlier. But if we wanted to figure out theta, we can use any of these lengths that we now know and plug them in. So for example, we could say sine of theta is equal to, what's my opposite? Well, it's a value of 3. What's my hypotenuse? Well, it's a value of 3 square roots of 2. We can't quite plug this into a computer because we have to get theta, or into a calculator because we have to get theta by itself. So to do that, we have to use the inverse function of sine called the arcsine function. And that will cancel the signs there and put the inverse sign over there. So that's going to be sine -1 over 3 over the square, 3 divided by 3 square roots of 2. And you plug that into a calculator. Bob's your uncle. You're good to go. Bob's not really your uncle. He's just a friend of your family. They just call him uncle because he's been around a long time. And we're going to find out that the measurement we get out of there, is 45 degrees. And the only flaw that we have in this right now is 45 degrees from what? And that's where it's useful to just have a graph to look at. We could change this to being something like, let's call it 135 degrees counterclockwise from X. And that would give us our answer. So that's how we use a lot of trig, and you guys are going to get practice with that. So save these notes, save this video if you need it. It shows you everything you need to do. I have one more thing that I need to just show you guys real quick, and that would be if you were given the hypotenuse and the angle. And that's what you're most often going to be doing with this part of vector mathematics. So let's do something that's easy for Mr. Terrell. We'll do a vector that is, yeah, we'll do this vector. Yeah, again, that's a straight line. I should never try and redraw. I could go back over it. There's never a time that I'm going to be able to make it straighter on my second try. Okay, so if I gave you this vector, and I told you this is an approximately 53-degree angle, and I told you that this was 5 units long, I might ask you, okay, can you give me the I and J coefficients for this? What is the X component of this vector, and what is the Y component of this vector? And so once again, we're just going to be using trig. We had SOHCAHTOA that I said. I'm going to specifically be using the sine part, opposite over hypotenuse, and the cosine part, adjacent over hypotenuse. So we can imagine that this angle that I've given you guys has this as its X component. That's what I mean by its, its I hat component. And this as its Y component, its J hat component. So now it's a triangle, and it's a right triangle, so fantastic. And it's a right triangle that we know that H is equal to 5. And we know that theta is equal to 37. Theta always being our angle measurement. So I can plug those in. Sine of 53 is equal to opposite over 5. I might have just said 37 a couple seconds ago. Please ignore that. If I wanted to get opposite by itself, I multiply both sides by 5. That cancels it there, but puts it there. So we get 5 sine 53 degrees is equal to my opposite length. And you plug that into a calculator, plug. I'm doing it in my head. Hopefully everything goes well. And it should end up being that the opposite length is about 4 units long. Going on the cosine part, again, we have adjacent for hypotenuse. We know that the hypotenuse is 5. We know that the angle is 53 degrees. So we can multiply both sides by 5. That cancels the 5 out there. We get 5 cosine of 53 degrees is equal to the adjacent length, and that ends up being 3 is equal to the adjacent, or pretty close, round it. So now we know our components. This right here is our x component. It's going over 3. Here we have 5. Oh, sorry. Oops, that was 4. 4j. And so using this, you can always do what's called, uh, it's either going to be called decomposing a diagonal vector, or we just found, oops, the x and y components. And over the next couple of weeks, you guys are going to be asked to do this and to practice this a lot. So these past 2 slides that I did, this video right here, keep it. Remember that you have access to it, and come back to it if you get stuck. So that's everything that you guys need to know for our first day. Thanks for tuning in. Good luck with the Pear Deck.